Now let us consider infinite bodies, each of mass m, placed along x-axis but not separated by equal distances. The first body is placed at x is equal to 0, second is placed at x is equal to d, third is placed at x is equal to 2d, the next one at 4d, the next one at 8d, and so on. We want to find the force on the body at x is equal to 0. The body at x is equal to 0 will experience infinity minus 1 or infinite forces. Of course, all these forces are not of same value. If all these forces are of same value, the answer would have been infinity. All these forces are not of same value. The reason is the distances are increasing, therefore the forces will be decreasing and the overall value will be a finite answer. Let us find what is that finite answer and what is the pulse of this problem. So here the first body will exert a force gm square by d square. Second body will exert a force gm square by 4d square. Then this body will exert a force gm square by 16d square. That body will exert a force gm square by 64d square. Let us call this as F. Then this will be F by 4, F by 16, F by 64, and so on. All these forces are acting in the same direction, so the resultant will be simply their algebraic sum. So the resultant is F1 plus F2 plus F3 plus F4 and so on. Let us substitute F1 is equal to F, F2 is equal to F by 4, F3 is equal to F by 16, F4 is equal to F by 64 and so on. F we can take common, we get 1 plus 1 by 4 plus 1 by 16 plus 1 by 64. If we pay a little attention, this is a geometric series where the first term A is equal to 1 and common ratio is equal to 1 by 4. The sum of this series is A by 1 minus R, that is 1 by 1 minus 1 by 4. So the sum of this series is F into 1 by 1 minus 1 by 4, that is 1 by 3 by 4. This can be written as 4 by 3F. And substituting for F, we get resultant force is equal to 4 by 3 gm square by d square. Now you will be very happy that you have found the resultant force due to infinite number of bodies. Same values may not be given, you may be getting different values. For that one, we must try to find the pulse of this problem. Now here you see the resultant force is F bracket 1 by 1 minus 1 by 4. From where we got this 4? Here it is given 2. 2 square is 4. So whatever number you find here, you take the square of that number here. Suppose in general it is n here, then you should get gm square by d square bracket 1 by 1 minus 1 by n square, or this can also be written as gm square by d square. This is n square minus 1 by n square, that will go to the numerator, n square by n square minus 1. This is the most general formula for any kind of infinite series. Now let us try to get some answers. Suppose here it is given as 0, d, root 2d, 2d, 2 root 2d and so on. So here n is how much? Root 2. Root 2 square is how much? 2. So this is 2 by 2 minus 1 is 1. The answer will be g m square by d square into 2 by 2 minus 1, that is 2. So 2 g m square by d square. Suppose it is given like this, the distances are 0d, 3d, 9d and so on. So here n is equal to 3. Then using that formula, resultant force R is equal to g m square by d square bracket. N is how much here? N is equal to 3. N square is 9 by 9 minus 1, 8. So you will have 9 by 8 g m square by d square. Like this you can find the resultant force acting on a body at x is equal to 0 due to the infinite masses placed along x-axis. After this, we will consider bodies present in a plane. If we take two bodies, they can form a plane. If we take three bodies, they can form a plane. They can form the vertices of a triangle. Triangle we can take, as simple example, we can take equilateral triangle and then right angle triangle. Then we can go for four bodies. Four bodies may be present at the corners of a square, or four bodies may be placed in such a way that three are at the corners of a triangle and fourth one is at the centroid.